going? All right. Hey, everyone. Can you hear us? Great.
I think so.
I think they can hear us? All right. Thank you so much for coming. So excited to see so many of you here on this day of Build. My name is Deborah Chen.
And I'm Thomas Weiss.
And we are both program managers on the Azure Cosmos DB team. And the title of today's talk is Best Practices for Cosmos DB on Data Modeling and Partitioning and RUs. And these are the three main concepts to know when onboarding to Cosmos DB in order to have the best success with the platform. Before we get to the content, I just have a question. How many of you have actually used Cosmos DB before? Wow, so many people. That's really exciting. And how many of you have actually used Cosmos DB in production? OK, so actually a lot. So you know if you've made it all the way from proof of concept to production, you've run into the concepts of data modeling, partitioning, RUs along the way. And we're here to give you some best practices. For those of you who are completely new, you'll be able to learn these best practices to get ahead of them when you start your workloads. And in this section, we're really going to be talking about how you can best structure data in a Cosmos DB collection, how you can choose the right partition key, which is another big source of angst for a lot of customers, and really appreciate how it differs, how data modeling in Cosmos DB is different from designing data model for a relational database. Any relational database users in the room? OK, almost the same set of people here. And today, we're going to be applying these concepts in the context of a real-world project to better learn from real-world examples. All right, so just a quick reminder for those of you who may be completely new to Cosmos DB. Cosmos DB is a database service. It's a globally distributed, multi-model database service in Azure that was built from the ground up to really address the problems of scale and enable you to build apps that scale from small amounts of data, small number of requests, to super large amounts of data, high volume of requests. At our core, we are a multi-model database, which means we support different data models, key value, column family, document, and graph. And on top of these, we have our multiple APIs or interfaces on top of them. Every best practice we talk about today is going to apply to the core SQL API, which is a native API we recommend you use if you're creating or getting started with new projects on Cosmos DB.
Great. So as Deborah just mentioned, the different concepts that we would like to discuss with you today are usually easier to understand when they are presented in the context of a real-world example and a real use case, right? So it turns out I am currently building a little pet project myself on Azure and Cosmos DB, obviously. I think I mentioned that to you, Deborah, before. It's a kind of a blogging platform. Okay? So let's imagine a website where users can register an account, and then they can publish blog posts, and they can also react to those blog posts through comments. So, you know, a pretty simple project, right, with very basic requirements. But it's an interesting use case because of the different kind of queries and requests that this website has to serve. So I was thinking, instead of just, boring our audience with dry slides, why should we just dig into the design of my little pet project? And as Deborah has worked with Cosmos DB for much longer than myself, maybe you can help me review my design and maybe improve it.
Sounds great. Let's see what you got.
Should we do that? Yeah. So let's head to the Azure portal. So here I'm using the Data Explorer that is integrated on the Azure portal in order to, well, explore my data and to see how my data model has been designed. So basically, on that little blogging platform, I have to deal with three kind of entities, right? I have users, I have posts, I have comments. What I did is to try to reuse those best practices and all those intuitions I've built from decades working with relational databases. So what I did, basically, I just created three different collections, one for each of my entity types. So first, I have the users collections. And if we look at the content, let it load. OK, here we go. So if we look at the documents in the users collection, it's pretty much the typical data that you would expect with a user profile. We have an ID, a username, email address, etc. The posts, pretty much the same ID. We'll let it load again. Yes. So each of my posts contains an ID. It contains also the ID of the user who has created the post. And then you find the usual content, the title, content, the creation date. And it's pretty much the same ID for the comments. I have an ID, I have the ID of the post that this comment is related to, and then I have the actual content of that comment. So pretty basic design, I would say, but well, it works for me. So what do you think, Deborah?
I guess you mentioned you used to work a lot with relational databases, and it looks like you have 3 different entities or types, and you have 3 different containers.
Yeah.
It can be a nice way to start, but oftentimes it might run into issues down the line in Cosmos DB. Have you run into any issues with the workload?
I don't think so, but I have to confess I haven't looked into the performance of my database for quite some time. So let's go down here to the metrics, and let's see what's the actual performance of my data model. So I would say everything looks fine to me. Except that, well, here it says that I have some requests that are exceeding the capacity. What does that mean?
So if you have requests that are exceeding capacity or this 429 error code, it means you're probably consuming more request units or RUs than you've provisioned.
Wait. More request units? Oh, okay, this is embarrassing. Can you tell me again what are request units?
Sure. So a request unit in Cosmos DB is how you provision the performance you want of your database or a container. We express the performance or throughput in Cosmos DB as the RU per second, and it's just an abstract unit that represents the cost of an operation via abstracting away the CPU, memory, and I/O. So think of you go to a store, you have $5, you can spend $5 worth of stuff. You have 5 RUs, you can do 5 RUs worth of requests. You can provision the RUs at either the database or the collection level. And in real workloads that people run in production, folks often scale them up and down programmatically based on their workload demands. A common scenario is you have a workload that's busy from 9 to 5 p.m. That's when all your users are using your site. And then you can scale up the RUs for that period of time and then scale back down in the evenings to help save cost.
Okay, so each operation I'm issuing against my Cosmos DB database has a cost in terms of RUs. What's the benchmark? How can I understand what's the cost of all of my operations?
The great news about RUs in Cosmos DB is that we actually tell you how many RUs every single operation costs via our SDK and portal. To give you a benchmark, to read a 1 KB JSON document, so very similar to that document you had in your collection there, it costs 1 RU. And to write that same 1 KB JSON document will cost 5 or so RUs. Query, of course, depends on the complexity of the query, how many documents you have to touch, what actually are you trying to do as an aggregate, is it just a select star? And that will depend, and the complexity of the query will impact the RUs that cost there. So it depends.
Okay, so the overall idea is that, let's say, if I provision a Cosmos DB collection with a provisioning of 1,000 RUs per second, then if I issue queries that each of them consume 10 RUs, then I can issue 100 of such queries per second, and I will be fine because I will still be within my provision quota. If I try to go beyond that, what does happen if I go beyond my provision quota, actually?
So if you go beyond your provision, let's say you provision 1,000, but you're now consuming 2,000, the SDK will actually retry on your behalf. So your request may still end up going through in the next second, but the end experience is you'll see end-to-end longer latency for those requests.
Okay, so because the SDK is smart enough to understand that there is throttling going on, it retries until eventually the request succeeds. But the symptom we see from a performance point of view is that there is increased latency. And that kind of rings a bell to me on my little pet project, because when I was checking my performance dashboard this morning, I saw that some of the requests actually were taking, say, longer than expected. And one of them was retrieving all the comments for one post. So what we can do now is get back to the portal and see how many RUs that particular request consumes. So I will go back to the Data Explorer. And then on the comments collection, the query to retrieve all the comments for one post would be select star from C, where c.postID equals, well, some ID. Let's try this one. So I got 100 documents back, but looking at the query stats, oh, wow. So that query consumed 136 RUs. Is that a lot?
That's actually a lot. If you think about your documents are pretty small and you're only returning 100 or so of them.
Right. So I guess we start to understand what's going on here. I have increased latency on my website. That's because some of my requests are expensive in terms of RUs, and that's a very common request, right? That's a request that many of my users are actually issuing from the website. And so because those frequent requests are expensive, I am probably going beyond the number of RUs that I have provisioned. And so those requests are getting throttled, and that's the source of the increased latency. So where do we go from here? Well, intuitively, I would say I just have to increase the number of RUs I've provisioned, and that should solve my problem.
Yeah, I'm actually curious for the audience. How many of you would just increase the RUs at this moment? All right, a few. For those of you who don't, you're smart, which means you're going to save a ton of money in the future. So raising the RUs would work in the short term. You would solve your rate limiting. But often when you see queries like this that have high latency, there's something deeper and fundamental going on that we should investigate.
Okay.
For example, if we dig deep into your query, looks like you're checking for post ID equals a value.
Right.
And ideally, your partition key should be able to be represented in this query.
Let me stop you here. Partition key, you lost me again. Can you tell me a bit about partitioning, because I'm not very familiar with that topic.
Sure. All right. So Cosmos DB uses a technique called horizontal scaling or horizontal sharding in order to scale out the data in your database. This is what enables you to scale from small number of data, gigabytes of data, to terabytes and even petabytes of data as your data grows. The idea is that Cosmos DB, instead of scaling up, which is a lot of what classical database systems do, you get bottlenecked, you buy a bigger and better machine with more storage, more memory, more CPU, and then one day you can't scale anymore. In contrast, what Cosmos DB does is it takes all the data that you have in your database or collection and distributes them among a number of physical machines, each responsible for a subset of the data. So the analogy here is if you're working in a team, you have 5 people, and you have 5 jobs to do. Each person will do one task. But it doesn't really make sense to give all the jobs or all the data to one person, and the other 4 people or the other 4 physical machines aren't serving any data at all. So when it comes to partitioning Cosmos DB, there are 2 main concepts to know. The first one is logical partitions. Cosmos DB takes all the data in your collection and groups them, all the ones with the same partition key value, into a logical partition. So if we were to partition folks here on stage, me and Thomas, then we have a document for each of us with our user ID, so Deborah or Thomas, and all the data where user ID is Thomas is in the same Thomas logical partition, and all my data for Deborah is in the same Deborah logical partition.
So essentially, those logical partitions are virtual group of documents, and all the documents within one partition, they share the same value of the partition key. So we'll have here 3 groups. One group with all the documents where user ID equals Thomas, a second one with all the documents where user ID equals Deborah, and so on and so on. But so why are we doing that? Why does Cosmos DB split documents into logical partitions?
So Cosmos DB takes all these logical partitions, and we distribute them among a smaller number of physical partitions or physical machines. This is the actual SSD-backed compute and storage where your data is living in some data center somewhere. So here we see in this diagram, the Thomas and Deborah partition ended up on this one physical partition, and this one Andrew one ended up on a different one.
So that's how we scale out, right? As you write more data to your Cosmos DB collection, the size of your existing logical partitions grow, but also maybe you have new logical partitions that are created. And in order to cope with that growth in data size, what Cosmos DB does under the hood is to automatically and seamlessly add more servers to the little cluster that is dedicated to your usage, and then it reshuffles your logical partitions across those different physical servers. That's how we scale out. So you probably start to understand that the choice of the partition key is key, with no pun intended, to a good design on Cosmos DB. What we want to achieve is to a set of well-balanced partitions. First, in terms of storage. You don't want to end up with, say, 1,000 partitions with one of them having 1 million documents and the rest just 5 or 6. What we are looking for is an even spread of storage across those partitions. Also in terms of throughput, you don't want to end up with a design where all your requests hits just one partition, because that would be an obvious bottleneck. Beyond that, the partitioning strategy is very, very important when it comes to the overall scalability of your data model. So if we take again that little example of a collection partitioned by user ID, and let's imagine that we are issuing that SQL query at the end, at the bottom of the screen. So that's select star from you, where u.user_id equals Deborah. So that query filters on user ID, which is our partition key. That means that all the results for that query sit in just one single logical partition, which is the green one in the center. And Cosmos DB is smart enough to understand that. And so what it does is that it routes that query to the one single physical server that actually contains that data. So by doing that, what we essentially do is that we decorrelate performance from data size. So it doesn't matter how much data you have in your collection. It doesn't matter how many logical partitions you have in your collection. That query will always just hit one server. And that's how we ensure scalability and performance at scale. So that's the best case. So that's what we ideally are looking for, queries that are filtering on the partition key of your collection. But we can also issue what we call cross-partition queries, right? So what happens in that case?
So in a cross-partition query, imagine for this query, we wanted to find all the users whose favorite color was blue. Now, we have no idea, Cosmos DB has no idea based on your user ID whether or not your favorite color is blue. So it needs to check every single physical partition, check the index, and return the result there. So that's the cross-partition part of that query.
And that's because and that's why those cross-partition queries are expensive, because instead of hitting one server, you have to hit all the physical servers that make your cluster. So that means more CPU, more memory, more I/O, and eventually more IOs. So I think I start to understand what's happening in my case, because back to the portal, as we mentioned before, that query filters on post ID. But back when I was creating that little database, I wasn't very familiar with partitioning. And actually, if we look at the settings, we see that this collection is partitioned by ID. So this is indeed a cross-partition query, and that's why it is so expensive in terms of IOs. So where do we go from here? How can we transform that cross-partition query into a single partition query?
So what you can do here is you can actually solve some of your problems by putting the data types that you often query together in the same collection. So your use case here is you have a blog post, and you have a bunch of comments, and you just want to show the blog posts and comments together.
Right.
If you could put those types in the same container, partitioned by post ID, which is what you typically query off, you'd be able to get much better query and read performance.
OK, so what you're suggesting, and through the magic of PowerPoint, I already have a slide, presenting what you were about to suggest. What you're suggesting is that starting from my current design, where I have 3 collections, each partitioned by ID, what I should do is to instead store my comments into the posts collection and change a little bit the partition key of my post collection, change it to post ID, because the partition key is a field that has to be present in all the documents within that collection. And by doing that, my comments would be partitioned by post ID, right? So I kind of get it, but I have to say I'm not super comfortable with the idea of mixing different entity types into the same collection. I mean, those 2 or 3 decades of relational modeling told me that this is bad, that this is something we should never do. So is it OK to do on Cosmos DB?
Yeah, I'm here to tell you today on behalf of the Cosmos DB team, this is totally an OK best practice, and you should not feel bad about this at all.
Cool.
So everyone here, it's OK. You can do this. This is actually the best practice in Cosmos DB, because you want to think about a collection not as a table like in relational database, but rather a logical container of all the different data types that you need to fit your workload. So in this case, the workload is blogs, posts, and comments. 2 different data types. You can put them in the same collection. This is a good use case when you have similar access patterns between them. You want to query on the same partition key, much like we want to do here for this work case.
Right.
And the typical way you implement this is to just add a new property in your JSON called type and just say what type it is. So it's either a comment or it's a post.
Mm-hmm. So I'm getting more comfortable with the idea now. But that brings another question to me. So what you are suggesting is that I mix posts and comments into the same collection. And so essentially, I would still have one document per entity, and those different documents would just reference each other, right? So like, for example, on top, I have a post, and then I have 2 comments related to that post, and those comments contain the post ID just to know that they are related to that post. So that's one way I can model that use case. But another way to do that is just to maybe embed everything in just one document, right? Because now posts and comments are in the same collection. So why should I just use my posts document and add an array of comments within that document? I guess we have some best practices here.
Yep. Actually, do you want to ask what the audience thinks? Which one they should use?
Yeah, sure.
All right. Who votes for, go back, the referencing one on the left? OK. Who votes for the one on the right? Okay. All right, let's go see.
Well,
All right, so in this case, you've actually hit on one of the key existential problems in data modeling, or questions in data modeling in non-relational databases, which is, do I want to reference the data, or do I want to embed the data? Referencing the data, like we did on the left-hand side there, is good when you have a one-to-many or unbounded relationship, many-to-many. So in this case, if you have a blog post, you can actually potentially have hundreds or even thousands of comments, which means you might be appending to a really, really long document. So it might be better here to actually reference them so you can continue to add new comments independently and not cap the number of comments per post. In contrast, embedding is good when you have a one-to-one or a one-to-few relationship. So for example, you have that user profile or the user profile container or collection where you probably have username, email, address, phone number. These things are usually queried together. They're one-to-one. They don't change that often. Good to embed them together.
okay, so in my case, let's say if in my posts I wanted to also store maybe tags, maybe references to external media, links to images. These are the kind of thing I could embed within the post because they really belong together and they share the same access patterns. When you update a post, usually you update those things together. But the comments, it's a bit different because first, I don't want to have an upper limit to the number of comments I can relate to a post, right? Because I can have thousands or even more comments per post. And also, and maybe more importantly, I want to be able to update or create a comment without having to rewrite the whole post document. So in my case, referencing makes sense. Right, thank you very much for your help. What I'm going to do now is, well, back to work. I'm going to update a little bit my data model based on what we just discussed, and I will let you know how it goes.
Great, see you tomorrow.
Cool. Hey, Deborah.
Hey, how's it going?
Very well. Well, let me tell you, based on our discussion yesterday, I have kind of massaged a little bit my data model, and I got some very interesting results. So let me share that with you. So right now, my data model, I'm down to just 2 collections, okay? Users collection, I didn't touch it. It's pretty much the same thing as yesterday. The biggest difference is in the posts collection, because now if we look at the documents, we can see that in that collection, I have posts, just like yesterday. The difference is that I have added a type field, so that type lets me discriminate between posts and comments when I query. And I also added a post ID, which is now my partition key. And in the case of a post, it's the same value as the ID, but that's how we do it. But I also have comments now. And same ID, I have a type equals comment for comments. So what we can do now is to take back that query that yesterday was taking 136 RUs and see how well it performs on that new model. No? So it's pretty much the same query, but we also have to filter on the type, because remember that collection now contains posts and comments, and I just want comments. So I'm filtering on type equals comment. I still get 100 documents back, but when we look at the stats, we're down to 8 RUs. So we have improved the performance of that query by an order of magnitude. And that really means 2 things. First, that request now is much cheaper in terms of RUs. So that means that I have less risks of getting throttled, and less risks of retries, and so less risks of higher latency. And so at the end of the story, that's a happier experience for the users using my website. That's one thing. The second thing is that because that request now is cheaper in terms of RU, I can run the same amount of requests with a lower provisioning. So I can actually lower the number of RUs I have provisioned on my database. And so at the end of the day, I'm saving money, which makes me happy as well.
Sounds great. And I think the nice thing to note here is that really we had a symptom, which was the high latency for queries, and we did some smart data modeling and really improved the performance overall.
Right.
All right, so how's your workload going otherwise?
So good question. Actually, I had another look at my little own performance dashboard this morning, and I noticed that there is another query that maybe has the same problem, because there is higher latency that I would expect. And that other query is getting all the posts for one user. So let's go through the same process. First, let's see how many RUs that query consumes. So in that case, the query would be select star from C, where c.user_id this time equals some user ID, and c.type equals post, because I want to get all the posts for that user. 92 documents are coming back, and that query, yeah, 122 RUs. So pretty much the same situation, right? That's a high, quite a high number of RUs for a query that's just returning less than 100 documents. Let's see if I can troubleshoot that by myself now that I'm rich of all the knowledge that I have gained over the past days. So that query is filtering on user ID and type, but it's executed against a collection that is now partitioned by post ID. So it's pretty much the same situation as yesterday. It's a cross-partition query that forces Cosmos DB to actually scan all the physical partitions underlying my collection. So again, same thinking as yesterday. If I wanted to improve that query and make it a single partition query, ideally, I would issue it against a collection that is partitioned by user ID. And turns out, in my current model, in my current design, I do have a collection that is partitioned by user ID, because if we look at the users, yeah, they are currently partitioned by ID, so that collection is kind of partitioned by user ID. Is this something we can leverage?
Yeah, I think you can totally take the data and copy it over to the second collection and do your queries from there.
But how would I do that duplication of data?
Great question. So there's a great feature in Cosmos DB called the change feed. Any of you familiar with the change feed? Okay, actually quite a few number of people. That's awesome to hear. Change feed is kind of one of the unsung heroes of the Cosmos DB feature set. And the change feed is an API exposed by Cosmos DB. You have it for every single one of your collections. And what it does is it's just a log of every change or update that happens in your collection. So what you do is you'll listen to the change feed. When anything changes, you'll listen to it. You'll trigger either your Azure function or the change feed processor library, which is the underlying library used by the Azure function. And when anything is changed, so there's a new document being written or an existing document gets updated, it broadcasts the change to your Azure function. We get you the full body of the document, and then you can write whatever code you want from there to do something. So that something could be copying the data to another collection.
Okay. So this time, what you suggest is that starting of my V2, what I could do is to actually listen to the change feed from the posts collection. And every time there is a new post created over there, or every time there is a post being updated over there, I would grab that document and just write it in the user's collection. So essentially, I would end up with 2 copies of my posts. On one side, my posts partitioned by post ID, and on the other side, partitioned by user ID. So I kind of get it, but that raises a couple of questions for me. And the first one is, how is that cost effective? Because what I will effectively do is to double the amount of storage I will use, right? Because for each post, I will have 2 physical documents stored in Cosmos DB, so that will double the amount of storage that I will be billed for. That's one thing. The second thing is that processing the change feed will have a cost in terms of RU as well, right? Because on one side, I need to listen and read from the change feed. On the other side, I have to write to the user's collection. And that's, there is no magic here. That will cost RUs. But right now, what we are trying to do is to improve the cost effectiveness of my solution. So how does that make sense?
I think the way to think about it here is for this workload, it's a very read-heavy workload. Or imagine on your site, more users are reading comments, reading blog posts, than necessarily writing to it. So for a read-heavy workload, if you want to optimize for this and get really good performance, then it's okay to pay the little bit of extra cost on the write path. So to be really specific, when you first write a new post, that's one write, and then the change feed reads it, that's one read, and then you write it to the second collection users, and that's another write. So all up for a 1 KB document, this might only be around 10 RUs or so. And when you're and by paying this 10 RUs here on the write path, you're essentially getting a 10x decrease in the amount of RUs needed for your queries. Furthermore, in Cosmos DB, storage is a lot cheaper than compute. There's 2 components, the RUs and the amount of storage you consume. And in this case, even if we double the amount of storage by writing posts twice, we've really made up that saving by not having to raise the RUs 10x to serve that same query.
So the rationale here is that my little blogging website, like most social apps, is read-heavy. I have many more users just browsing the website to read posts versus users that are actually creating posts. And in that kind of situation, it really makes sense to make those writes a little bit more expensive, even if it's twice as expensive. If, on the other hand, those very, very frequent reads can be optimized by, again, an order of magnitude, just like we did before. So again, that's a kind of a change of mindset that is pretty important for us developers and DBAs coming from a relational background. We used to always think in terms of normalization, and we should always optimize for storage. Now we are running in the cloud where storage is dirty cheap, and compute is way more expensive than storage. So duplicating stuff over storage is not a big issue if on the other hand, we can optimize the compute and spend less on the compute. So again, that makes a lot of sense to me. And again, back to Visual Studio. I will update my little data model again and get back to you once that is done.
See you tomorrow.
Sure. Hey, Deborah.
Morning. How's it going?
Yeah, well, better than ever. Let me tell you, I have, again, updated my data model, and now it's running really well. I mean, I had another look at my performance dashboard this morning. Everything is running fine. Most of my requests are very low latency. My users are super happy. A quick look at the data model now, but I guess that you probably project what I'm about to say. The posts, same thing as before. Now the posts contain posts and comments. The main difference is in the users collection, because now in the users, I have posts like before. If I find one, maybe I can just filter, where seed.type equals user. Here we go. So I have users with type user, but I also have posts. So those posts actually come from the change feed. Every time a post is created or updated in the post container, that thing gets automatically replicated, duplicated into the users collection. And let's do the same as before. Let's try again that particular query that was taking 122 RUs yesterday. And let's try it again now on my users collection. Same query. And now it just takes 10 RUs because we switched from a cross-partition query to a single partition query.
Great. Looks like you've really improved the performance of your workload there.
Definitely.
Quick question. I see that new collection, Leases. What's that?
Oh, good question. I nearly forgot. So Leases is a collection that is dedicated to the Azure function that is running my change feed processing. Okay, so it's just a little collection that contains metadata and configuration for my Azure function to run. And maybe I can show you what it actually looks like. So I have here an example of an Azure function that gets triggered every time something happens in my posts container. Here we go. So it's just a basic C# function, and that code gets called every time there is new data available on the change feed. And so what I'm doing here in that example, I'm just logging the actual content of the document I'm getting from the change feed. And to see it in action, it's pretty easy. We just connect to the log streaming service for that particular Azure function. And now let me go to my posts collection, and I will just briefly modify a document. Let's maybe add an S here. I hope my users won't mind. I will save that document, go back here, and what we'll see is that that updated document shows up on the change feed. And it's indeed my updated version, because if we look at the content, I have an S here. Okay. So that's how it works. That's how every time there is new stuff happening in the post collection, I replicate it in the users collection. So that's a typical example where we use the change feed in order to just move data across different Cosmos DB collections. But I guess that many of our customers can use the change feed with different purposes.
A lot of customers actually use the Cosmos DB change feed to implement event-driven or microservice-like architectures. So what they'll do is they'll have Cosmos DB as the source of truth for every activity that's happening on their website. So customers like ASOS.com, Jet.com are running their shopping carts on Cosmos DB, and every time a user goes there and adds an item to the shopping cart, that generates a document in Cosmos DB. They have a ton of Azure functions all listening to the same collection. So you add an item to the cart. One function is listening to calculate the tax, which is different for every region the user is in. There's another one that's actually checking, do I actually have this inventory in stock? There's another one that's actually running the credit card payment processing. So all these functions or microservices listening to the same Cosmos DB using the change feed to trigger some downstream event.
Cool. So now I'm very satisfied with the way we have optimized my data model. My website runs faster. I'm saving money because of those optimizations, I can lower the amount of RUs I've provisioned. You know, life is good. Now that my website is running fine, what I want to do is to get a better understanding of how my users are using that website. So what I was thinking to build after that, and again, that's something I shared with Deborah before, is to add a kind of analytics service, something that would let me track what's happening on my website. So the idea is that every time something happens on the website, let's say every time a user views a page, every time a user clicks on a link, that's an event that I would catch and store in a Cosmos DB collection. Obviously, I could do that with Application Insights, which is a great product that I love, but you know, I just like to rewrite everything myself. That's how I go. Some people share that mindset, I guess. So I started to think about how to model the thing. And my initial intuition is the following. Again, based on the conversations we had over the past days, I understand that I have to think in terms of querying, right? I have to think ahead, how will I query my data? And based on that, I can figure out how to actually partition my data. In the case of my event storage, I'm probably going to query it by date, because you know, those will be temporal queries. I want to, for example, fetch how many views a particular page had over the last day, over the last week. So I was kind of guessing that maybe the date would be a suitable partition key. What do you think?
Yeah, why don't we actually try a few different choices of partition key, measure the performance and throughput we're getting, and see which one's the best one.
Sure, please.
All right, so I've actually mocked up a little bit of your analytics service here. I've got a sample JSON document that just has things like user agent, where the source of traffic was from, who the user did the activity.
So that's typically the kind of event I would log into my Cosmos DB collection.
Yeah. Mm-hmm. And what we're going to do here is I've actually written a very basic simulator that's going to generate documents that look like this, write it to Cosmos DB at a high volume, and see the throughput we get.
So what we are going to do is to simulate the load of such an analytics service that will spit a lot of data at very high throughput and see how the choice of partition key makes for better or worse throughput.
Yeah. So yeah, in this case, I've actually created a collection called partition by date. It's partitioned by date. And I've given it 50,000 RUs, which is quite a lot of RUs.
That's a lot.
Yeah, should be able to handle any write ingest.
Well, it has to, because you know, I'm expecting millions of users using my website, and I don't want to lose any point of data. So I really want to be able to ingest each and every event that's happening on my website.
All right, so let's run my simulator. Let's run partitioning by date. And we're going to print out exactly how many writes per second we're getting with this partition key. Seems like it's taking a while.
Yeah. That's not
What do you think is going on here?
Well, maybe we are hitting some kind of bottleneck, right?
Yeah. Looks like we're only getting around 700 writes per second, not even getting anywhere close to the whole 50,000 RUs we've provisioned just at 14 seconds to do this. And if I had to wager why, if you think about it, you have a bunch of data coming in, and they're all coming in on today's date, May 8th, which means they're all literally writing to the same logical and physical partition as we speak, which is creating a bottleneck.
Right. And we did provision 50,000 RUs on that collection. So that's basically the kind of, that represents the amount of hardware resources that Cosmos DB is dedicated to my usage. But because of the choice of partition key, because in that case we are only hitting one partition, that's a physical bottleneck that doesn't let me reach the amount of RUs that I have provisioned.
All right, so what other ideas do you have for partition keys?
Maybe from the audience? So what I was thinking, because I will be tracking what's happening on my website, a common thing to do is to also store the source of the traffic, right? Is my user coming from Facebook, from Twitter, from Bing? So that's the traffic source, if you say. Is it something we can test?
Yeah, we could test it. And looks like, how many different traffic sources do you have?
About 10, maybe?
OK, so definitely more than the data, at least.
Yes.
All right, let's try it out. You won't believe it, but I actually already have that container created behind.
Yeah, that's pretty crazy.
Let's do this. I can read the lines. All right, looks like it's actually a lot better. We're getting around 1,700 writes per second, using 16,000, 17,000 RUs, but we're still not using the full 50,000 RUs.
So what's happening here is that in the first example, all the events were written with the same value for the partition key. So all the events were funneled on the same machine. Here, we have 10 different potential values for my traffic source. So that's 10 potential different logical partitions that we can write concurrently to. And so that means we can better spread our bandwidth over our hardware resources, and then so we can achieve higher throughput than before.
Yeah. But still, a best practice here for write-heavy workloads is you really want that high cardinality of distinct values coming in. So do you have any other ideas for partition key values that maybe have more unique values? All right, we had random number, region, the hour. Okay, user ID, post ID.
Yeah. It's not that difficult of a question, is it? So, I mean, ideally, I would have a partition key that lets me achieve a high write throughput, but also would help me when querying, because as we have seen before, cross-partition queries can be expensive. So it's about finding the middle ground between the two things. So the next thing we can try is to actually partition by what we call a composite key. So it's a field that is composed of the post ID, or let's say the page ID, and then the actual date when that event was recorded.
Yeah, and the thing here is this isn't something that lives in the data set. You actually have to generate it on the client side in order to get it, right?
Yeah.
All right, so let's run this. Wow, look at that.
Yeah.
We're now getting all the RUs Cosmos DB promised us we would get. And
Yep, go ahead.
Yeah, so I'm very happy about that. We're now not wasting the RUs. And let's actually go to the portal and see what that data looks like.
Mm-hmm.
So here, dragging this out, in this one container, I have a ton of items. Let me zoom in. And you see I have this new field called partition key, which is just taking the post ID and then underscore the current date. So if I wanted to query for all the events or user activity for this one post, I could write a new SQL query, okay, where C partition key. Now I can do this in clause, where let's say I want to look at it on May 8th, but I also want to see what happened yesterday. So because I understand the construct of my partition key, I can just construct it based on what I want to query for. And when I run this, okay, looks like we only had one user ID for this one post, but it would show everything from either today or yesterday or any other dates you want to put in this where clause.
So that's a good compromise, because we have a partition key that lets us write to a lot of different logical partitions at the same time, concurrently. So that means we can really use the entire number of RUs that we have provisioned, but also because this partition key is, I would say, query-friendly, it lets us do single or just few partitions query at the same time.
Great.
So yeah, just to repeat a bit what we said, that scenario of the analytics service was very different. I would even say is the opposite of what we discussed initially on the front end, right? The front end, in the context of the front end is you have a lot of reads, you don't have that many writes, but the performance of the reads is very important because the low latency means you have a good user experience for the people using the website. The analytics service is pretty much the other way around. We have a lot of writes, because those are the click streams of everything that's happening on the website, so a very high write throughput, but you have very few reads, because using an analytics service, I will query maybe once an hour, once a day, just to see what's happening on my website. And by the way, I don't expect those read queries to be very well performing. If it's not that real time, that's not a big deal. So in that context, we have to think about another approach when it comes to the partitioning strategy. We have really to make sure that writes can be evenly distributed across those different partitions to achieve the throughput we are looking for. Let's quickly go through those different lessons that I have learned personally from working with Deborah today, and I hope that you people also benefited from that. First thing, and when we said at the beginning of the session that designing a data model for Cosmos DB is different from designing a model for relational database, the first thing to take into account is that your eventual data model is really dictated by the access patterns. In a relational database, you think about storage, you think about the actual content of what you are about to store. Cosmos DB, on Cosmos DB, it's not that much the case. You really have to think about which are the most frequent queries that you will eventually issue against your data model, and you have to work around those queries to make sure that your data model will serve those queries well. The ideal situation, when you start a new project, you are able to kind of project yourself into the near future to understand what will be the actual usage of your data model, and then build it on top of that. Obviously, the partitioning strategy is super important when it comes to the actual scalability of your data model, because a good partitioning strategy lets you decorrelate performance from data size. Okay. I know that it can be a little bit stressful to think about partitioning because maybe it's a new kind of concept for people who usually don't work with distributed databases. And I know that for some people there is a kind of partitioning anxiety. What if I do take the wrong choice? What if my partition key is not the best one?
Yeah, first of all, if that happens to you, has that happened to anyone who's run Cosmos DB in production? All right. So actually quite a few people. And you are not alone. Partitioning is something that's really important to invest in time up front. But in the worst case that you do, let's say you make a less than optimal choice and you run all the way to production, there's a couple options for you. The first one is you're going to use that same change feed feature that Thomas showed, where instead, again, you can copy your data to a secondary collection, and you can just change the partition key of that one. And because the change feed is running live, this is actually a live migration or live copying of data without any downtime for your website. In general, it is best if you can, of course, to spend some time like we did up here, iterating through various data models and getting it right after doing some load testing as well. Thank you so much for coming to this session. Hope you took something away around data modeling, partitioning, RUs, and for follow-ups.
Yeah, if you want to follow up, and especially if you appreciated that iterative and progressive approach that Deborah and I took today in that session, I would highly recommend you to check that first link, aka.ms/practicalcosmosdb. That will redirect you to a new article that we have recently added to our documentation. That article pretty much covers the same kind of use case, and it explains you step by step how to model, start with a V1, measure the performance, understand what's going on, and how to improve your model. It's a very good article, and I know that because I wrote it. Okay? CosmosDB.com obviously is the place to go for all our documentation. We also have a side website called gotcosmos.com, and that's where you will find additional content. So you have some workshops, some guides, and some samples that you can find there. Definitely bookmark that link because we plan to use that gotcosmos.com a lot in the near future to add more content. And obviously, you are very welcome to come down to the expo floor and to chat with us. Thank you very much.
Thank you. So we have about 10 minutes left. If you want to stay, we can take questions here at the microphone.
Is live?
All right.
So how come you didn't do it the opposite with the users in the post, as putting the users into the post?
So the question was, in our use case, we put the posts and the users. Why didn't we put the users in the post? I think that would have worked too.
Yeah,
Yeah.
all depends on the, again, all depends on the eventual access patterns that you expect. In our fake example, say that we needed the users to also sit in the users collection and be partitioned by user ID for some reason, because maybe we want to, do some queries that leverage that kind of partitioning. It would have worked, but for the sake of our demonstration, we just wanted to show also the different ways to move data around.
Because you would actually probably have less duplication if you put the users in the post, because you most likely have more posts than you do users.
That's true. That's true. That's also, yeah. So that's not the kind of thing that really should worry you, because again, storage is cheap. We charge some cents per gigabyte. So, but yeah, to your point,
There's more RUs involved in creating more posts, right?
that's true as well. That's true as
So
well.
it would be
Yeah,
cheaper to actually do it the other way.
that's true. Yeah,
Thank you.
sure.
So I have a question in regard to updating data. So
Yeah.
in your example, we're like adding records, but how would you approach, let's say we've changed the post, but now we have a post embedded, with the user. So in that flow, how does that update work?
So the question was, in our current presentation, we assumed that we were going to add a new document and then use ChangeFeed to copy it to the second collection. But what happens is instead of a new document, we're updating it instead. So again, ChangeFeed will trigger both on new documents and updates. So you update that document, we'll see it, and then you can use the upsert functionality just to upsert the corresponding document on the other side.
Okay, and can Matt, one more follow-up.
Yeah.
So like, let's say the change feed is being triggered from the post. What about from the other direction? Is there a correlation from like an order of operations? So if you came in and an operation was performed on the user that in turn affects the internal post, could that then update the actual post, logical collection?
Yeah, I guess that's the kind of chain you can implement. What you have to take care of and be aware of is, infinite loops. You don't want, change feeds to trigger each other. So in your case, if you are receiving changes through either Azure Functions or some custom code, always filter on some properties, right? For example, we have posts and comments in the post collection. You just want to duplicate the posts. You filter on the posts, on the type post, to make sure that you're not getting in that kind of infinite loop between different change feeds.
So, but I guess that's just one more thing you need to consider.
Yeah.
Like both architecting your data, but also just the process for adding and updating the data.
Right.
Yeah. Thank you.
Thank you, Arret.
Hello. Also regarding the change feeds and the embedding technique that you showed, what are the techniques, or what should I be worried about with data getting out of sync? What is the degree of reliability that I have that the change feed will actually keep both my collections in sync if I query one and the other? So what are the kind of the times that I have SLAs for propagation of the data through data feeds? And what kind of, and in your example you showed Azure Functions, do you think they're enough to guarantee that my data is always going to be in sync, and how to avoid that?
So we have a library called the ChangeFeed processor. That's a library that we have built and that we support. That ChangeFeed processor kind of guarantees what you are worried about, because it takes care of checkpointing, it takes care of retrying, and that thing ensures that there is no loss of data when processing the change feed. And the actual implementation of the Azure Functions triggers is based on that change feed processor. Okay? So whether you use Azure Functions or you implement your own change feed processing, as long as on your side you also use that change feed processing library that is available on GitHub, you should be safe.
And from your perspective, if the data is logged is in Cosmos DB, it's already in the change feed. And you can also, using that same library, say let's say you need to process everything from the beginning, you can do a start from true and then pretend every document came in for the first time and then do any reconciliation there if you need to do that.
So I can go to my boss and say, this is safe, let's do this. Trust me.
Yes.
It's different, but it's right.
You can quote us.
You can quote us.
Okay.
We also have a ton of customer stories around ChangeFeed as well. So companies like ASOS.com, Jet.com are all building their shopping carts using ChangeFeed Cosmos DB, and they're running in production.
And in their use cases, if they were losing one event, they could be losing money. So yeah, they bet high on the change feed.
Yeah.
Thank you. Great presentation, guys.
Thank you.
Thank you.
Thank you.
Hey, so you guys give an example of embedded scenario, right? So how does the reference scenario would work when you're cross-referencing the partition key?
So in that example,
Actually was
yeah, what we were saying is that we were going to put posts and comments into the same collection.
Yeah, so that is embedding, right?
Either you can embed, so end up with just one document containing, say, your parent data and all the related data, or you can just put all those data items into separate documents, referencing each other through IDs. But in terms of partitioning, it's the same because all that data sits in the same collection, so they are all partitioned through the same partitioning strategy.
Okay. And we also talked about the change feed, right? So what if I have made a mistake and now my data volume grows and now I realize that my partition key was wrong. So you mentioned that change feed will help me for new data or update data coming up. What about the existing data? So any best practice for that?
yeah, so the question is, so change feed might be able to help me, copy new data or existing coming in, but what about new data? So like I mentioned for the previous person, for a change feed processor library, so not functions, but the library itself, you can set a parameter to start from the beginning, start from true, beginning true, and that will actually give you the stream of every single document that ever got created in your collection from the beginning of time. So you can then reprocess everything there and do your logic to copy it to a second collection.
So, but will I be able to schedule that because it might impact my RU, right? Because if I have millions of rows, if everything goes at one time, I may cross my limit.
Right. So yeah, you can decide to run the change feed processor library to start anytime you want. So on my dev machine, I can control F5, start it, and then can close it to kill it. So you can schedule it based on when you want to do it.
And remember that you are very flexible with the RU provisioning. So if you are about to do a migration, and just for the next hour, you're going to use the change feed to kind of copy all your data from one collection to the other, you can crank up your RUs just for that time window in order to execute fast. And then once that's done, you can lower them again.
Great.
Yeah.
One last question. We talked about the partition key. What about the indexing? Is there any concept of indexing and how does it work and hand-to-hand with partition?
Yeah, do you want to actually show the portal for this one?
Sure.
So the thing to think about for indexing is Cosmos DB does automatic indexing of every single property in your document by default. For write-heavy scenarios, a lot of times users actually don't want to spend the incremental RU cost on indexing new documents for writes that they might never even query on. So if you want to really, really optimize for writes, you can completely turn indexing off. So in this JSON file, if you turn automatic to false and indexing mode to none, then you'll save the RU cost on the indexing. You can also, let's say you only have one thing that you always query on and the other 20 properties are just there. You can also selectively index that property as well, which will also save on your RU cost.
But to your question, indexing and partitioning, they work together.
Okay.
But the partitioning strategy helps to direct your queries to just one machine or just one subset of machines. And then locally on those physical servers, we use indexing to further boost the performance.
Great. Thank you.
Thank you.
Hi, my question is, does it mean, if I keep my entities in separate collections, does it mean that I certainly have them kept in different partitions? Or I can somehow settle two of the collections to use their key to be considered as if it is the one?
Yeah, the different collections will always use separate physical partitions. I mean, you shouldn't take any assumption about the locality of your data when they are in different collections. Partitions are below collections. So different collections, different partitions for sure. And there is no way to merge those things.
In this case, is there any reason why I should use multiple collections instead of just one, apart from logical from the perspective of the architecture?
So the question was, we talked about how you should move types to the same collection. Are there any use cases where I actually should have different collections? So the main use case there is if you basically need a different partition key. So for example, here in the users one, assuming we had a separate page on Thomas's site that was showing your user profile, maybe your avatar and whatever else, that one will often query by user ID, so you want to partition by user ID. In contrast, the post container, we always want to query by post, so we'll partition by post. Every collection can only have one choice of partition key. So if you need different collections to support different querying patterns, then you can do that. So one example we actually had was an airline who was building a CRM system on Cosmos DB, where if you've ever called an airline for customer service, where maybe your flight is running late or got canceled, and they ask you what's your phone number, what's your email, or frequent flyer number, and you just have to give them one of them. So this airline this customer did the POC where they found out they had a large volume data that if they partitioned by email address, queries on email address were great, but then queries on the loyalty number or the phone number were very slow. They were cross-partitioned. So what they ended up doing is they actually created 3 different copies of their data. So one was partitioned by email, one by frequent flyer number, one by phone number, and depending on what value the user gave, the application would just make sure to query the right Cosmos DB collection and then get that data very quickly with low RUs. That's a kind of use case where you might want to have different collections for your data.
Okay, and one more question on yet another question on change feed. So as long as I get it, it is reasonable in some cases to duplicate data if I know that it is read more often.
Right.
Have written. So let's say I have pretty complex data structure, and in this case, I decide to copy the name of the user who made a comment in order for it not to be read once and once again.
Yep.
So what should I do in case if the user changes his alias or name or whatever? I guess I should use this change feed, but
Yep.
If the structure is complex, then this user name copy may be stored in number collections in different parts of the documents and so on. Does it mean that I have to enlarge the sync process, or there is some pattern, for instance, keep back reference or whatever, maybe some best practice on that?
That exact example you just gave is pretty much covered in that first link. It's one of the examples I'm covering in that article. So we denormalize usernames into posts. What if the user updates her username? So yeah, I invite you, of course, to check the article. Basically, the long story short, we use the change feed to be notified every time there is such an update, and then we run stored procedures in order to update username for all the users matching that ID. That's an expensive operation, that's for sure. The rationale here is that it's a very rare operation. You know, when a user creates an account, it's very rare that eventually she will update her username. So it's an expensive operation, but it's acceptable considering that it doesn't happen that often.
I'm not really aware. Stored procedure is something on Cosmos DB.
Yeah, yeah.
Thank you.
You're welcome. I think, yeah, we have to leave the room. Maybe we can take the rest of the questions just between us. Yeah, please come at the.
Yeah, over here.
Thank you very much.
Thanks so much.